A pleasant morning, dear students. In last class, we have discussed about Unit 3 fluids. Okay, today we will continue the lesson. In last class, we have discussed about the introduction of fluids, thirst and pressure. What is thirst and what is pressure, and pressure in fluids and liquids, factors determining liquids pressure in liquids. Okay, so then atmospheric pressure. Okay, these are all discussed in the last class. Okay, today we are going to discuss about the measurement of atmospheric pressure. One of the most instrument used to measure the atmospheric pressure is called as a barometer. Okay, so let's see the construction and working of barometer. A mercury barometer, first designed by an Italian physicist Torricelli, consists of a long glass tube, okay, closed at one end, open at the other end. One end is closed and one end is open. Okay. Then it will filled with mercury and turned upside down into a container of mercury. This is done by closing the open and end of the mercury filled tube with the thumb and then opening it after immersing it into a trough of mercury. Okay. The barometer works by balancing the mercury in the glass tube against the outside air pressure. The air pressure increases, it pushes more of the mercury up into the tube, into the top, and if the air pressure decreases, more of the mercury drains from the tube. As there is no air trapped in the space between mercury and the closed end, there is vacuum in that space. Vacuum means there is no air. Okay, empty space. Vacuum cannot exert any pressure. So the level of mercury in the tube provides a precise measure of air pressure, which is called atmospheric pressure. This type of instrument can be used in a lab or weather station. So this barometer, what is the purpose of barometer? How it can be used? This type of instruments can be used in a lab or weather station. Okay, so barometer. So then next we will move to the problem. Okay, so a mercury barometer in a physics laboratory shows a 732 millimeter vertical column of mercury. Calculate the atmospheric pressure in Pascal. Okay, so what are the given value? That is a pressure P. It will be given in a millimeter, so we will be converted into meter. So that is 10 power minus 3. You can multiply with that value. Okay, so then what is the rho value? You know very well about that. That is given density of mercury is 1.36 into 10 power 4 kilogram meter minus 3. Then what is the gravity value? You know that is 9.8 ms minus 2. So what is the formula to calculate the atmospheric pressure in the laboratory? So now we can calculate, that is what is the value of H, that is 732 into 10 power minus 3, and rho is 1.36 into 10 power 4, and G is 9.8, and you have to multiply the three value. Finally you got 9.76 into 10 power 4 Pascal. Okay, so when you keep the before one digit, okay, so we can get the value of 0.976 into 10 power 5 Pascal. Okay, so in this way some of the problems asked in your exams. Okay, so next we will move to the Pascal's law. Okay, so what is Pascal's law? Pascal's principle is named after Blaise Pascal. Okay, so in the year 1623 to 1662, a French mathematician and physicist, the law states that external pressure applied on an incompressible liquid is transmitted uniformly throughout the liquid. Okay, so that is known as the Pascal law. Okay, so the law states that an external pressure applied on an incompressible liquid is transmitted uniformly throughout the liquid. Let's see the demonstration. Pascal's law can be demonstrated with the help of a glass vessel having holes. Okay, so having holes. all over the all over its surface. Fill it with water, push the piston, the water rushes out of the holes in the vessel with the same pressure. The force applied on the piston exerts pressure on water. This pressure is transmitted equally throughout the liquid in all directions. This principle is applied in various machines used in our daily life. Okay, so the one of the machine based on the Pascal's law is hydraulic press. So let's see next. Okay, so what is the demonstration? You know very well about that. Fill it with first take one vessel. Okay, glass vessel having holes. Okay, all over the space, holes. Fill it with water, push the piston. In the above container, the piston is there. Okay, push the piston, the water rushes out of the holes in the vessel with the same pressure. So why? The force applied on the piston exerts pressure on water. This pressure is transmitted equally throughout the liquid in all directions. This principle is applied in various machines used in our daily life. Okay, so next we will move to the hydraulic press. So this principle of the hydraulic press is known as works under the Pascal's law. It consists of two cylinders of different cross-sectional area is shown in the figure. They are fitted with pistons of cross-section area small a and caps A. The object to be lifted is placed over the piston of large cross-sectional area caps A. The force F1 is applied on the piston of a small cross-section area A. The pressure P produced by small piston is transmitted equally to a large piston, and a force F2 acts on A which is much larger than F1. Okay. So pressure on piston of small area A is given by, that is P, which is equal to F1 by A1. So applying Pascal's law, the pressure on large pistons of area A will be the same as that on the small piston. So what is the pressure of the piston? P, which is equal to F2 into A2. Comparing these two equations, finally we got F1 by A1 which is equal to F2 by A2. We find out the value of F2, so you have to multiply it with A2 in that side. So F1 into A2 by A1. Okay, since the ratio A2 by A1 is greater than 1, so the force F2 that acts on the larger piston is greater than the force F1 acting on the smaller piston. Hydraulic systems work in this way, known as a force multipliers. Okay, so what's the name? Hydraulic systems working in this way are known as force multipliers. Okay, so next we'll move to the density. Okay, so what is density? You know that. So what is the formula for density? Density is nothing but mass per volume. Okay, so the density is defined as, the density of a substance is the mass per unit volume of a given substance. Okay, so what is the formula? So that is a mass per unit volume of a given substance. Okay, that is known as a density. So the SI unit of density is kilogram per meter cube. Okay, because what is the unit of mass? You know that is a kilogram. Okay, what is the unit of volume? That is known as meter cube. So finally the unit is kilogram per meter cube or kilogram meter minus 3. Okay, so how to find the density formula? We know that the value of M and V. Okay, so easily we can calculate the density. What is the formula? Density which is equal to mass per volume. So we know the value of M and V. Finally we calculate the density. Okay, so we understand clearly. Let's do an activity.